You guys ever wondered how is the production of this plastic bag?
Oh, I also wonder about that. How about you, Farid?
Let's try and search for it.
Our topic is blown film extrusion. Extrusion process used to make a plastic or film. The extrusion die is formed like a circle shape and air pressure is utilized to stretch the film further. The polymer is solidified once it has been enlarged to the required dimension and specifications.
Before we move further, let us introduce ourselves. My name is Muhammad Farid bin Juari and my magic number is 2019262564.
My name is Muhammad Danish Daniel bin Nazaruddin and my magic number is 2019428482.
I'm Awangku Muhammad Zul Hisham bin Awang Baswandi. My student ID number is 2019237984 and we are from class J4EM1104E and we are group 2. These are the points that we are going to talk in this video presentation.
This is the flow process for blown film extrusion. The first one is mixing. Various densities of polyethylene are mixed together to form a homogeneous mixture consisting of low density and high density polyethylene. These are usually in the form of plastic beads. The second one is melting. The mixture is then melted in an extruder which melts the polyethylene around temperatures of 350 to 500 Celsius. Next is pumping air. This produces a film of plastic which is polyethylene in the shape of a tube as air is being pumped vertically through it. Then it passes through roller. Slowly, the plastic tube is cooled down and rolled into sheets by multiple rollers that will eventually form the plastic bags. And lastly, heat seal and cutting. After sheets pass through the rollers, the bags are made by heat sealing and cutting the rolls film. The machine that does this heat sealing and cutting do its job according to the measurements installed to draw out the required length of one plastic bag. So, if it's small plastic bags, the machine cycle speeds can go as high as 70,000 bags per hour. But in cases of large polyethylene bags, it can go as slow as 200 bags in an hour. So, this is the control parameters in the extrusion process. The first point is the polyethylene pellets are melted at 200 degrees and pressed. Then, the second point is the die length creates back pressure and decrease melt flow speed. The mandrel regulates die opening to control melt flow speed and the heaters control the temperature of melt. And at the tube, it has a minimum thickness of 37 microns and also a circumference of 51 centimeter. And let's proceed with the safety procedures and safety method. We go to the safety procedure first. The first one is never wearing anything that dangles, such as necklace, braces, watches, rings or loose clothing to prevent limbs from getting trapped or pulled into the machine. Also, we must know where the location of the nearest fire extinguisher and the nearest first aid kit. The most important thing here is never operating the machine without authorization and appropriate training. And let's move on into the safety method. So for the safety method, the first point is height. Some extrusion, notably blown film, runs upward into a cooling tower. There may be places where tools or other loose objects can be left, and if they fall, can injure people or damage machinery. Next is floor. Look up to spot objects that could fall, but look down too. Pellets, water, and oil are my main worries. Cluttered should help avoid pellets, slips, and by mopping oil leaks. And drips isn't so easy, as water will not mix with the oil. Cleaning the mop in detergent-rich water may work. The last one is pressure. Insulate melt transfer tubes and be aware of the danger of their breakage or separation when melt expands on reheating after full shutdown. And stay away from the die opening as much as possible.
This is the illustration for the blown film extrusion process. So, we move on to the next slide, the advantages. Blown film has a better balance of mechanical properties than other extrusion process like cast or extruded films, because it is drawn in both the transverse and machine directions. Mechanical properties of the thin film include tensile and flexural strength and toughness. The nearly uniform properties in the both directions allow for maximum toughness in the film. In addition, blown film extrusion die can make many different widths and sizes without any significant trimming. This high level of flexibility in the process leads to less scrap material and higher productivity. Furthermore, blown films also require lower melting temperatures than cast extrusion. Measured at the die opening, the temperature of the cast film extrusion is about 220 degrees Celsius, whereas the temperature of the blown film is about 135 degrees Celsius. Furthermore, the cost of the equipment is approximately 50% of the cast line. Further disadvantages, blown film has a less effective cooling process compared to the flat film extrusion. Flat film cooling is done by the means of chill rolls or water, which have significantly higher specific heat capacities than the air that is used in the blown film cooling process. The higher specific heat capacity allows the substance to absorb more heat with less change in the substance temperature. So next, if we compare to the cast film, blown film has a more complicated, but they have less accurate method to control film thickness. Cast film has a thickness variation of 1 to 2% versus the 3 to 4% for blown film. So the resins used for casting typically have a lower melt flow index, which is the amount of polymer that can be forced through a standard die in 10 minutes according to a standard procedure. The melt flow index for the cast film is about 5 grams per 10 minutes, whereas for blown film, it is about 1 gram per 10 minutes. Consequently, the production rates for the cast film are higher. Cast film lines can reach production rates up to 300 meter per minute, where blown film lines are usually less than half this value.
We proceed to the next slide, which is defect for this blown film extrusion. So, what is defects? Defects is any form of deviation of the product's characteristic from the specification set up by the manufacturing process. It can be caused by a single source or the cumulative effect of the several factors, which may arise at any stage of the processing. Resin defects are a type of defect that can occur during the extraction process. Due to resin contamination, a chemical reaction in the extruder that may generate gases. If moisturized, induced in the resin is not removed by an atmospheric or vacuum vent, it exits the die as steam and causes holes in the product. It can cause surface play on the extruded part. Next is poor mixing. Cooling is provided to prevent resin or additives from prematurely melting and sticking to the feed through. Uniform heating around the whole die, transfer pipe and adapters is critical to guarantee consistent polymer flow out of each die hole if fans or other cooling device are blowing on one side of the die. This can affect melt temperature. This impact on the product quality can create the clogging in the extrusion. Last but not least, overheating. Melt occurs in single screw extruder primarily as a result of shear heating of the polymer. Shear heating is the result of a polymer filled screw rotating within the barrel. Overheating may produce degradation of polymer material that is used or make dimensional control and sizing difficult. And it can create the problem in the cooling of product.
To sum up, the blown film extrusion process is widely used around the world for the production of plastic bag.
Companies in Malaysia itself, such as Ecoplast Sendirian Berhad and Tiong Chuan Plastic Sendirian Berhad, are the examples of the manufacturer that applied this extrusion process.
Due to its high production rate, it becomes the most promising process to produce plastic bag. That's all from us. Thank you. Assalamualaikum.